जी हाँ, अभी हम डिस्कस करने वाले हैं मॉलिक्यूलर कंपाउंड्स को. Previously we discussed molecular compounds. We discussed the force of attractions which are present in molecular compounds, and then we discussed the effect of these force of attraction which are present on the melting and boiling points of these molecular compounds. And okay, now yes, just going towards our textbook. You see, this is our textbook. Let me open that particular topic which we have to discuss today. And the topic is about molecular compounds, the melting and boiling points of molecular compounds. Usually the questions from such topics will be asked like that. Uh, why few molecule has low boiling point? Why few molecule has high boiling point? So today we are going to discuss this question. Previously we discussed question number 3. Now we will discuss question number 4. What would you, let me read that question. What would you expect the strength of the bonds to be like between carbon and oxygen atoms in carbon dioxide compared to the strength of forces between neighboring carbon dioxide molecule? First of all, let me write that questions in whiteboard so that we can make our notes in proper wordings. The question is, we have to compare strength of bonds, we have to compare forces, we have to compare forces of attraction and strength of bond. We have to compare forces of attraction and strength of bond between two molecules in such a way. Just imagine you have a carbon dioxide molecule, carbon dioxide, CO2. The structure of carbon dioxide is like this: C double bond O and C double bond O. We discussed these structures when we were discussing covalent bonding. Okay. So now we have to explain the strength of bond which is present between this carbon atom and this oxygen atom, and you have to compare this strength of bond with another carbon dioxide molecule. Just imagine this is another carbon dioxide molecule, and this is another carbon dioxide molecule, and the forces of attraction are like that. There are force of attraction between the carbon of this carbon dioxide and the oxygen of this carbon dioxide, and there is force of attraction between the oxygen of this carbon dioxide and carbon of its neighboring carbon dioxide. And now what we have to compare? We have to compare the force of attractions which are present. We have to compare the strength of bonds which are present between this carbon and this oxygen, like this one, and between these two neighboring carbon dioxide molecule. We have to compare this force of attraction with this force of attraction. We have to compare the strength of this bond with strength of that bond. So what would you expect? Which force should be strong? This bond, this bond is known as this force of attraction, and this strength of bond is known as intermolecular, right? Oh no, intramolecular. It is intramolecular. intramolecular. Previously, we discussed in detail what is intramolecular, and this is intermolecular. Intermolecular, and we now obviously intermolecular forces are not much strong. Intermolecular bonds are not much strong as compared to intramolecular bonds, intramolecular forces. So the strength of bond, this bond is strongest bond. This bond is a strong bond as compared to this bond. So the answer of this question is the answer of this is the question number 4 of your textbook. While going to write the answer of this question, first of all, just draw these two structures and then write down these points. And let me write these points here. The bond which is present, the bond which is present between carbon atom and oxygen atom is strong bond. Strong bond. Why? The force of attraction, because the force of attraction is high here. Because there is strong force of attraction, strong force. Because there is strong force of attraction between carbon atom and oxygen atom. Between carbon atom and oxygen, between carbon atom and oxygen atom of same carbon dioxide molecule, within the carbon dioxide molecule, within the carbon dioxide molecule, carbon dioxide molecule. The bonds which is present, the bonds which are present. The bonds which are present between carbon atom and oxygen atom is strong bond, because there is a strong force of attraction between carbon atom and oxygen atom within the carbon dioxide molecule. While the force of attraction, while the force of attraction between carbon atom of one carbon dioxide molecule and oxygen atom of another carbon dioxide molecule, while the force of attraction between carbon atom of one carbon dioxide molecule, one carbon dioxide molecule and oxygen atom of other carbon dioxide, other neighboring carbon dioxide molecule, while an oxygen atom of others neighboring carbon dioxide, and oxygen atom of other neighboring carbon dioxide molecule is not very strong. Is not strong force. Is not strong force. while the force of attraction between carbon atom of a one carbon dioxide molecule and oxygen atom of other neighboring carbon dioxide molecule is not strong force. So just we have to compare this force of attraction, we have to compare this force of attraction with that force of attraction. And we know this force of attraction is much stronger as compared to that force of attraction. And we just have to write these things as the answer of this one question. Okay, then for next question, just we have to search a little bit by using the help of internet. We have to seek help from internet for that question, because this is a little bit conceptual question. Would you just let me write here? Would you expect methane to have high or low melting point? Would you expect methane to have high or low melting point? Like, yes, it has low melting point, but let me find a proper wording. Yes, methane has a not strong melting point. Very important lines. They have mentioned very important lines. Okay. So our next question, which we are going to discuss, is that questions, very important questions from exam point of view. Question number 5. Methane consists of molecules containing one carbon atom covalently bonded to four other atoms. Would you expect methane to have high melting or boiling point? Explain this answer with reasoning. We have to explain this answer with reasoning. First of all, let me write the statement of questions so that we can make our proper notes. This is the question number 5. And you can take the statement of question number 5 from your textbook as well. Let me write these questions. Would you expect? Let me write a little statement of questions. I am not going to write the statement fully because this takes a lot of time. Your time is very precious. So would you expect methane to have high melting points or low melting points? Would you expect methane to have high melting point or low melting point? Yes. Before going to the answer of this question, just to summarize what we have discussed previously. What actually melting and boiling point is, and how can we decide that this substance has low melting point and that substance has high melting point? how can we figure out, how can we decide this substance has low melting point or whether this substance has high melting point? Actually, there are forces of attractions among neighboring molecules. And if these forces of attractions are strong enough, then we need a big amount of energy to overcome these forces of attractions. This then when we provide a big amount of energy, then this indicate that that substance has high melting point. But if the forces of attractions are not strong enough among molecules, if the forces of attractions are not strong enough among the molecules, then we don't need to provide a big amount of energy to overcome these forces of attractions. Then such substance, when we provide a little amount of energy, when we have to provide a less amount of energy, such substance has low melting point. Let me write this answer in proper wording. I have explained the concept which is behind these questions. The answer is methane has low melting point, not high. Methane is a gas, a burning gas, which we really have in our kitchen and in our stoves. Here in Pakistan, we call that gas soy gas. And I think you are pretty much familiar with soy gas. Methane has low melting point. Melting point, let me write that sentence to make you concept crystal clear about melting point. Melting point and boiling point. And boiling point is determined based on how neighboring molecules interact with each other. How neighboring molecules interact with each other. Interact with each other. If this interaction among neighboring molecule is strong enough, then we need to provide a big amount of energy. We need to provide a huge amount of energy. This increases the melting and boiling point. But if this neighboring interaction, if the interaction between neighboring molecules is not very strong interaction, then we don't need to provide a huge amount of energy. We just provide a less amount of energy to overcome this force of attraction, because this force of attractions are not strong enough, and this indicates that such substance has low melting point. Okay. So, very conceptual question this is. Bonds in methane are very much covalent bond, very much covalent. But it also is symmetrical molecule. But structure of methane is symmetrical. But structure of methane is symmetrical. But structure of methane is symmetrical. This means methane does not have positive and negative charges. This means Methane, this means methane molecule does not contain positive or negative charges, positive or negative charges. It means there is a not strong force of attraction. Due to this lack of attraction, they just due to this lack of attraction, due to this lack of attractions, means it means amongst different methane molecule there is no strong force of attraction. Due to this lack of attraction, methane has low melting point. Methane has low melting point. Okay, I hope you got my point. So up till here we discussed what melting and boiling points of molecular compounds. We have discussed what my molecular compound is, and what simple molecular structure, and how covalent bonds are there in different molecular structure. Then we try to understand melting and boiling points of molecular compounds and how forces of attractions play with these melting and boiling points, how forces of attractions can increase melting and boiling points, and how forces of attractions can decrease these melting and boiling points. Then we try to answer these questions. These are the very important questions from exam point of view. Usually in exam, they ask questions from such pattern. So you don't need to be worried. You don't need to be much worried about your exam preparations. So you don't need, I am saying again, you don't need to be much worried about your examination preparation, because in the exam they ask questions from this pattern. Usually they take questions from this pattern, and sometimes even they take questions from these questions. They put these questions in your exam question paper as well. And we have to discuss question 3, question 4, question 5 with proper answer and proper wording. Now the next topic is about conduction of electricity. Okay, very important from concept of ionic bond, and we missed that concept in ionic bond. Conduction of electricity means the flow of electricity. Conduction of electricity means flow of electric current. It means flow of electric current. And what electric current is? Electric current is basically flow of electrons, flow of charges. Flow of charges is called electric current. Flow or flow of charge, or movement of electron, or we can say movement of electrons. Movement of charged particles is much better word. Movement of charged particles is called electric current. This is, you can say, the definition of electric current. The movement of charged particle is called electric current. And electric current is a flow of charged particles. Simple, and you know, in simple molecules, there is no charge. Usually charges are there when something is present in case of ions, when we talk about ionic compound, and when ionic compound is overall, although ionic compound overall neutral, but when we put an ionic compound in aqueous solution, This ionic compound split into positive and negative ions, and this negative and positive ion is responsible for electric conduction of electricity. Simple molecule. But when we talk about molecular compound, simple molecules have no overall charge, and so cannot carry any electric current. In a covalent bond, electrons are shared between two atoms, as you know. The strong forces between negatively charged electrons and positively charged nuclei hold the electrons in place. They cannot move. Electrons cannot move. So molecules cannot conduct current. The electrons cannot flow and so cannot carry a current. So I am telling you, the question will be asked from that point, from that paragraph. The question would be like that. Why simple molecules cannot conduct electric current? Why molecules cannot conduct electric current? The answer of this question will be written in these lines. And before going into polymers, just if we solve this one questions, explain why water is a poor conductor of electricity. This is also very important questions. Why water is a poor, why water, explain why water is a poor conductor of electricity. But before solving this, if we open the slides, slide. Simple molecules. Okay. So conducting electricity. Now we are discussing this one. Conducting electricity. What is required for an electric current? Very, very, very important point. What is required for an electric current to conduct through a material? We understand, it's very understood now that what actually conducting electricity means. Flow of current. Flow of current is called conducting electricity. And to conduct electric current, what material need? Material need two things. Material need two things to conduct an electric current. Free moving electrons is required to conduct an electric current, and we will study detail this topic when we study chapter about electrochemistry. The other things which is required for an electric current to conduct is free moving ions. What would the covalent bonding is? Simple covalent molecules, just they do conduct electricity. Very important point. Let's open this one. No. The answer is simple no. And I have explained you in detail why the answer is no. The question here mentioned is, what would the covalent bonding in simple covalent molecules suggest? So do they conduct electricity? The answer is no. And I have explained earlier why the answer is no. Because in simple molecule, there is no free electrons, there is no free ions. And we know that to conduct electric current, we need free moving electron, we need free moving ions. But in case of simple covalent molecules, no free electron is available, no free ion is available. So let me write this one. So here once again, as no free electrons and no free ions are available, so they do not conduct electricity. So simple covalent molecules do not conduct electricity. So they do not conduct electricity, right? So the next question is, water is the poor conductor of electricity. Explain why. Let me find this proper answer. Oh yes, the answer is very interesting. The question is, let me show you once again that questions. Explain why water is a poor conductor of electricity. Question is, explain why water is poor. Why water is poor conductor of electricity. The answer of this question is a very important question I am mentioning here. Because water exists in solution as electrically neutral molecule. Water exists in solution form as electrically neutral molecule. As electrically neutral molecule. As electrically neutral molecules. The molecules carry no electric charge. The molecules carry no electric charge. And there are no ions in solution to carry charges. And ions are not available, and free moving ions are not available. Free moving ions are not available. So water is a poor conductor of electricity. So water is a poor conductor of electricity. Okay. So the next topic is polymer, and we will discuss polymer in the next class. But here we think we should start with the definition of polymer. What polymer is? What polymer is? Before going into polymer, there is another term, and we call that term is monomer. Monomers. What monomers are? Simple molecule, small simple molecule. We call them monomers. And when, just imagine this is a monomer. Just let me write here. Polymers. Topic name is polymers. And before going into polymers, we must understand what is monomer. Monomers. Small simple molecule. Small simple molecule is monomer. Just imagine this one. Just imagine this is a small simple molecule. We call it monomer. And what polymer is? Different monomers. Combination of monomers is called polymers. Combination. This monomer is combining with another monomer, different monomers. The combination of different monomers make a structure big, make a big structure. the combination of different monomer make a big structure, and we call that structure a polymer, right? So let me open slide as well. Slide. Yes. Monomers are a type of simple covalent molecule. They fit the general properties of simple molecule we have covered today. However, they have the ability to join up and form a long chain of repeating monomers. We call these polymers. Previously, we make structures like that. These are different monomers, and these different monomers combined together. And the combination of these different monomers is called polymer. The longer the polymer, the more intermolecular forces it will have, and higher its melting and boiling point will be. When different monomers combine together, then what happened? Structure become a long chain structure, and this long chain structure has a more intermolecular forces, so it has a high melting and boiling point. So my dear student, I am going to finish this lecture at that point, and I am going to share all these notes with you. If you have anything which is confusing, if anything, do you feel anything which confuse you, without any hesitation, you can ask, you can discuss it with me. So let me share these pages with you. Okay, thank you so much.